Hi everyone, this video is about an alternate acid-base definition or another acid-base theory besides the one that we've already discussed, which was Arrhenius's definition of acids and bases, acids being H plus producers and bases being OH minus producers. You may have noticed when you looked on table L for the list of common bases that only 3 out of the 4 bases had OH minus within their formulas. This fourth one, aqueous ammonia, has no OH minus in sight, and yet it's still listed as a base. And that's what this alternate theory is going to help us explain, is why we consider NH3 a base, even though it doesn't have the hydroxide ion that Arrhenius says all bases have. So by this alternate acid-base theory, our main statement is this. Acids are going to be recognized as H plus donors. And that's really no different from Arrhenius's definition. He just said that acids produce H plus in water. So they're kind of giving away H plus to the water. That's great. We're going to continue rolling with that idea that acids are producing H plus. We're just replacing the word produce with donate. So acids donate H plus. If acids are doing the donating, bases, their opposite, must be around to do the opposite or accept H plus. So we're going to define bases by this alternate theory as H plus acceptors. There are thousands of multiple choice questions that just ask for this basic definition that acids are H plus donors, bases are H plus acceptors. So kind of lock that into your memory. What we can look at here is kind of that definition in action with the example of ammonia. So I'm going to label my ammonia N, and here are its 3 H's. And ammonia is shown here interacting with water, H2O. So here are our H's and our O. And what we see happening here is that between these two frames, this H from water came over and hung out with the ammonia molecule and created NH4 plus, or the ammonium ion. So that H plus was donated by the water and accepted by the NH3. So that ammonia now has this extra H plus, and water has donated or kind of lost it to the NH4 plus. We're left now with OH minus. So by this alternate acid-base theory, what we see is water acting like an acid. Even though we know water is a neutral compound, here it's acting like an acid because it is donating an H plus. And ammonia is our base because it is accepting that H plus from the water. And that helps us figure out why we classify NH3 as a base, because ultimately, check out what ion is left over here in our products, OH minus. We've created something basic. So even though it didn't come directly from the NH3, it was the NH3 that coaxed water into producing OH minus. So this alternate theory is important to remember. Acids are H plus donors, bases are H plus acceptors, and you're often going to see these examples shown as reversible reactions. So that double arrow is showing us that many interactions between acids and bases are in fact reversible.